Okay, let's try a problem from chapter 18. Suppose that a photon has a wavelength of 650 nanometers. What is its frequency and what is the energy? Okay, let's solve for the frequency first. Let's work on A. We know the wavelength is 650 nanometers. We know C, the speed of this photon, it's always the same. It's the speed of light, which is 3.00 times 10 to the 8th meters per second. And we're looking for the frequency. Well, we have the equation C equals wavelength times frequency. And we can rearrange it by dividing wavelength on both sides, and now we have an equation that is the speed of light divided by the wavelength equal to frequency. We have it solved for frequency. So you might be tempted to plug in the numbers, but before you do that, let's take care of one thing. This is meters per second, right? That's the unit there. Frequency we want in 1/2. Our wavelength is in nanometers. We need it to be in meters to cancel out this meters and the speed of light. Okay, because the unit is going to be meters over second divided by meters, and we'll get the meters to cancel. But right now it's in nanometers. So let's convert that. Take 650 nanometers, and we say for every 1 nanometer, we have 10 to the negative 9th meters. You can look that up. That cancels with that, and so now we have 650 times 10 to the negative 9th meters, or you could also say 6.50 times 10 to the negative 7th meters. Okay, so this is what we're going to use for our wavelength. So let's plug in the numbers here. Speed of light, 3.00 10 to the 8th, divide by 6.50 times 10 to the, what was that, negative 7th. That's what I prefer to use. Okay, and this will get us in something 1/2 for the frequency. Now, I'm going to do some math in my head. If I have 10 to the 8th divided by 10 to the negative 7th, what you do with these exponents is you take 8 minus a negative 7. You add or subtract the exponents whenever you divide or multiply. And so it's whenever you divide, you subtract the second one, but this is a negative, so really we should have an exponent of something close to the 15th. And if we plug this into our calculators, you should get 4.6, I'm rounding up to 4.6, times 10 to the 14th. Okay, that's what you should get. Remember, use parentheses, that can help. Sometimes that's a problem if you don't use parentheses. Okay, so, and don't forget the dot there, that's 6.5 times 10 to the negative 7th. Alright, so we have the frequency. Right, now we want to know what the energy is. So the energy of this photon, we don't know. Well, we know the frequency of it. We just solved for that. It's 1/2. We know, well, what equation has energy and frequency? Well, how about this one? The energy of a photon is equal to Planck's constant times the frequency. And we know Planck's constant is a constant, it's always the same. And H is equal to 6.626 times 10 to the negative 34th. And that is a joule second. That's a 34. That's a joule second. Okay. Alright, so now we have, and if we look at this equation, we have F, we have frequency, and we have H. So by looking at the units, if we took a joule second times a 1/2, second will cancel out. We will get joules, and energy is measured in joules, so that's a good thing. So just plug in your calculator, 4.6 times 10 to the 14th, and multiply that by 6.626 times 10 to the negative 34th. Hit equals, don't forget your parentheses, and your unit will be joules, and that's the energy of this photon.